Now that we have learned how to use the quadratic formula, we're going to focus on a small part of it called the discriminant. So the discriminant is the portion underneath of the radical, our b squared minus 4ac. And the discriminant has an important job in the fact that what happens under that radical has a big part in determining whether I'm going to have a real solution and how many solutions I'm going to have. So if that b squared minus 4ac is less than 0, meaning a negative number, there are going to be no solutions because you're going to get a negative number underneath of there, which is only an imaginary number. So if we get something less than 0, we know we're not going to have a real solution there. Case 3 is when b squared minus 4ac is greater than 0, meaning we get a positive number. Okay? When that happens, we get what we're normally used to. We get two real solutions because I can take the square root of whatever's in there and then it's going to get added and it's going to get subtracted. Remember that plus or minus. But the one case that we haven't seen a whole lot of so far is what happens when that b squared minus 4ac is equal to 0. So we get square root of 0, which is 0. Well, remember, it's always plus or minus, but I can add 0 or I can subtract 0. I'm going to get the exact same thing. So I'm not going to get two different answers this time. So I'm only going to get one solution because square root of 0 is just 0, so there isn't a positive and a negative version for us to add. Okay? So that discriminant can very quickly tell me whether I can actually get a solution to this problem and what I might get for a solution, and then I can go ahead and actually solve it to figure out the rest of it. Okay? So for each of these, we're just focusing on the discriminant. Okay? b squared minus 4ac, and we want to use that to determine the number of solutions we're going to have. So we'll tackle a couple of these here. So here's my a, my b, and my c. So b squared, 2 squared, minus 4 times a times c. Okay. It's no longer equal to 0 because I'm not doing the whole equation. So I get 4 plus 36 is 40. I got a positive answer. So I'm going to have two real number solutions. Next one, here's my a, my b, and my c. So b squared, negative 7 squared, minus 4 times a times c. So I get 49 plus 96 is 145. Again, I got a positive number, so I'm going to have two real solutions. Okay. Now what if I jump down to number 4? Well, remember, none of this works until it's in standard form. So I need to kind of move the x and the 4 over. So I get 4x squared minus x minus 4 is equal to 0. So now I have my a, my b, and my c. So b squared minus 4 times a times c. So I get 1 plus 64 is equal to 65. So I have two real solutions. Okay. Let's take a look at this number 5. So I got 3x squared minus 13x minus 10 is equal to 0 because I had to move everything over to the left-hand side, put it in standard form. So I have b squared, negative 13 squared, minus 4 times a times c. Okay. So I get 169. Remember, a negative times a negative, so negative 13 squared is a positive 169, plus positive 120 is 289. So we have two real solutions. Number 6. So it's already in standard form, so we're good there. So we go ahead and we find our numbers. So b squared, so negative 10 squared minus 4 times a times c. So I get 100, oh, not 1,000, 100, minus 4 times 6 times 10, which is 240, gives me a negative 140. Since I got a negative number, remember this is going to be in my radical, this is going to be no real solutions. Okay? And then let's do number 9. And then by then I think you'll have a pretty good taste for it. So again, it's got to be written in standard form. So I need to rearrange my pieces. 9x squared minus 18x plus 9 is equal to 0. So negative 18 squared, b squared, minus 4 times a times c. So I get 18 times 18 is 324, minus 4 times 9 is also 324. So I'm going to get 0. Remember, that is what's in my radicals. I'm going to get the square root of 0, which is 0. So when I go to do the rest of the quadratic formula, I'm not going to have anything left there to add or subtract because I'm adding 0 and subtracting 0. So this is going to be one real solution. Okay? All right, and then I'm going to jump to the very last one, the word problem, because I want you to kind of see how this works in a real world situation. So it says, Lupe tosses a ball up to Quyen waiting at a 3rd story window with an initial velocity of 30 feet per second. She releases the ball from a height of 6 feet. The equation h equals negative 16t squared plus 30t plus 6 represents the height of the ball after a certain number of seconds. If the ball must reach a height of 25 feet for her to catch it, will the ball reach? Okay? So what we want to know is, am I going to get any real solutions? So I don't need to know the actual solutions. I just want to know, am I going to get any actual solutions for it? So I can use my discriminant. So I'm going to plug in 25 for my height. So 25 is equal to negative 16t squared plus 30t plus 6. I'm going to move my 25 over to put it in standard form. So I get 0 is equal to negative 16t squared plus 30t minus 19. And now all I want to know is it going to reach? I don't need to know the exact amount of time. I just want to know, is this going to happen? Meaning, am I going to get a solution that's going to work? So the best way to do that is use my discriminant. How many solutions can I expect? If I'm going to get 1 or 2 solutions, then I know I'm probably going to have an answer that will work. If I'm going to get no solutions, then it means it couldn't reach that height based on this equation, and I know I won't have a solution to it. So I'm going to do b squared, 30 squared, minus 4 times a times c. 30 squared is 900. 4 times negative 6 times negative 19 is 1,216. Subtract, and I get a negative 316. Again, this is the part that was going to be under my square root. I can't take the square root of a negative number. So this is no solution, meaning there is no, based on that information in the problem, based at the speed of the ball and the effect of gravity built into that equation, it will not reach her at 25 feet high. It's going to come up short, meaning that there's not a solution that will satisfy this particular problem. All right.